Hello, in this video we will be using the dot product to find the angle formed by the main diagonals of a cube. We have over here a cube I made using GeoGebra. I need to write the coordinates of some of the vertices of the cube since we are going to write the displacement vectors for the diagonals. So I'm going to write over here that the point B we have over here has coordinates 1, 0, 0. So one step in the x directions, no steps on the other two directions. Of course, I could make the cube of any size I want, or I could call this point S0, 0 for more generality, but it really doesn't matter from the point of view of finding the angle because all the figures we're considering would be similar if we make them in different sizes. So that's my point B over here, and the point H here has coordinates, no steps in the x direction, one step on the y direction, one step on the z direction. So I would like to write the displacement vector HB. So I'm going from H to B and I want to know the steps I need to take. Well, I can do that by writing 0 minus 1, 1 minus 0, 1 minus 0. We have here first the components of H minus the components of B. So this is the vector minus 1, 1, 1. Remember, this is telling us that to go from H to B, we need to go one step down on the x direction, one step forward on the y direction, one step forward on the z direction as well. Okay, I also want to write the vector that represent the displacement from E to C. I'm going to write the coordinates of the point E as 0, 0, 1. And for the point C, the coordinates would be 1, 1, 0. So I will be writing 1 minus 0, 1 minus 0, 0 minus 1. So this displacement vector has components 1, 1, minus 1. Now I would like to find the angle between those two vectors. To find the angle, I want to use the geometric representation of the dot product that says that when I'm finding the dot product between two vectors A and B, I could find that as the magnitude of the vector A multiplied by the magnitude of the vector B multiplied by the cosine of the angle between them. So in this case, well, actually we want to find the cosine of the angle, so we can isolate that and write it as dot product of the vectors divided by the product of the magnitudes. And this is what we are going to do for our vectors H, B, and EC. We are going to write over here their magnitudes. We are going to have for the first one, we are summing the square of the components and then taking the square root of that. So that gives me the square root of 3. And when I do that for the other one, no surprise over here, we need to get the same value, right? Because we know that those two diagonals have the same magnitude. So to find the cosine of the angle theta, we will be doing the dot product between the two vectors. So we'll be multiplying the components and summing them. So negative 1 multiplied by 1, that's negative 1, plus 1 multiplied by 1, plus 1 multiplied by negative 1. So that's equal to negative 1. I'm missing right in the denominator over here. I will have square root of 3 multiplied by square root of 3, and also have then square root of 3 times square root of 3, that's going to be a third. So I'm looking for the angle theta that has a cosine of negative 1 over 3. So we're going to need to ask our calculator about this. So in the calculator, we are trying to find the inverse of the cosine of minus 1 divided by 3, and that is approximately 109.471 degrees. Wait a minute, we say that we actually wanted to find the acute angle, not the obtuse one. We got the obtuse one, so we're going to need to do 180 minus the answer that we got. So we get our answer of approximately, to three significant figures, 70.5 degrees.